Today we're going to be talking about how to use your graphing calculator to graph these functions. So first, we're going to explore this function. F of x is equal to a sine bx. So make sure you write that down in your notes. And we're going to go straight to your graphing calculator, and we're going to graph this basic sine function right there. So here's my HP prime. The first thing you want to do is hit the top right corner here, and make sure you're in radians. So again, make sure that pi symbol is selected. If the degree symbol is selected, your graphs are going to look pretty weird. So make sure, again, you select the pi symbol for radians. The next thing we're going to do is go to apps, make sure you're in function, and notice how I already have some functions in here. If you have that, just clear them. That's perfectly fine. Just shift clear. And I'm going to type the first function in, sine x. And if you take a look, you should have something like this. Now, if you look at the worksheet, we want to actually match the scaling of the worksheet. So to do that, hit Shift, Plot, and right here is the table for how you control what the calculator is looking at. So for our table, what we're going to do is make the x range negative 4 pi to positive 4 pi. Notice how it changes it to 12.5 because it's multiplying 4 times 3.14. And the x range, we're going to make that negative 5 to 5. And the x tick is like what every tick mark is worth. So in the x direction, we want this to be pi. And in the y direction, it'll be 1. And again, we're just copying the settings on the graph that I gave you for this worksheet. So now when I graph it, now that fits exactly our worksheet. So if I go back to our worksheet now, let's just copy that graph I saw. So we can see that the y-intercept is 0. It goes up to 1 in the middle between pi, and it follows this pattern here, like this. So the graph looks something like this. And I'll follow it in the opposite direction. And there we have it. You've now graphed your first sine wave. Now let's answer the questions that are given. This y of 0, that's an interesting way of writing y-intercept. So in this worksheet, you'll see that a lot. The y-intercept here is clearly 0. The max value is referring to the highest the graph will ever go. So that's up here. That's 1. The min's the lowest it'll go. So that's these 4. Negative 1. And now we have amplitude and period. So to do that, we're going to go back up to our notes now. So these graphs, to sketch them, I want to use a sideways T like this. A typical sine wave looks something like this. Starts at the origin, goes up, hits the middle, and comes back. This has a nice wave like this. That's going to be a typical sine wave. Now the amplitude is going to be right here. Think of it as like the height of the wave, amplitude. And then the period is going to be right here. That's 1 period. So in short, think of the amplitude as, again, like the middle to the top or middle to the bottom. And some people say height of the wave. And the period, I think of the period as this. The time it takes to complete one wave. So if you look at our original sine wave we graphed here, I'm going to highlight this part right here. You'll notice that this right here is one wave. And the time, or the x values it takes to complete one wave, here to here, it's 1 period. that is 2 pi. So you're going to write 2 pi for the period, and the amplitude, you can just look here to here, that is 1. And now what's interesting about this is, again, this continues forever. If you go back to your calculator, if you want it to scroll very carefully, notice how it continues forever. But on our graph here, if I were to ask you to section it off, hopefully you can see that there are actually 4 periods here. 1, 2, 3, and 4. Okay, so there's our first graph. Now let's go to cosine. So go back to your calculator, hit symbol, change that to cosine x, and we're going to graph it. And all we're going to do is copy this down. So I'm going to go back to my worksheet. Cosine is pretty similar. The wave is almost identical, except it starts at 1. So it starts at 1, then hits the bottom at -1 at pi, then 2 pi, 3 pi, and 4 pi. So it looks something like this. And again, we'll continue it the other way too. So we have our complete graph here. So our y-intercept, we can look right there. That is 1. The max is 1. Min is -1. Now for amplitude and period, let's go back up to our note section. Let's talk about f of x is equal to a cosine bx. Again, draw your sideways t. A typical cosine wave is very similar to a sine wave, except what I said earlier, it starts at the top. And it ends at the top. So it looks something like this. That's going to be a typical cosine wave. So over here, if I were to section it off, you can see it starts at the top here, and there would be 4 waves of the cosine function. So the period here is still 2 pi, and the amplitude we can see, if I zoom in here, middle to the top is the same as the last one. It's 1. Okay, so that's the first 2 examples for you. You have to finish the rest of these problems, and as you're working, I want you to figure out these 2 questions. What does that do? And what does this do? Again, you're looking for what does this A do? What does that B do? So now that you've graphed those problems on your calculator, let's summarize what you should have hopefully realized. In your generic form here, this A is the amplitude, and to be precise, we say the absolute value of A is the amplitude. This B relates to the period, so that's why I wrote period is equal to the absolute value of 2 pi over B. So those are the relationships you should have hopefully realized. And the answers for this are below. And some other things you might have realized is sine always starts at the middle. So you'll notice that the y-intercepts are 0 here, 0 here, where cosine is starting at the max or min. So you'll notice that the y-intercept for cosine is 1 and 2. So max if it's positive, so that's like this one. And this is also positive, so that's why it's 1 as well. If it started at the min, that would mean cosine is negative. So if you look at like D, for example, we can see it starts at -3, which is the min value, which tells you it's a -3 cosine. Now what's tricky is people want to say this, that sine starts at 0. However, that's not true. Because if there's a vertical shift, like in this one, we can see that it's starting at 1, but the max is 4, the min's -2, which means this graph must have gone up 1. So that's why it's more precise to say sine starts at the middle, because the middle is a more accurate way of explaining what's actually happening. It's just often 0 because usually there is no shift, especially in these early graphs. We're seeing in this one, there is a shift right there, and that's why it's starting at 1.